simplifying like terms, and we're going to start by showing it with Alegtiles again. I know that we've done some of this already without Alegtiles. You'll probably find that drawing Alegtiles is kind of annoying because it takes extra time, but sometimes drawing it is really helpful for us understanding. So if I was doing this question with Alegtiles, I'm going to take this first one, 3x, and draw 3 x's. Those are the long rectangles, and you can draw them upright or sideways. This time I decided to draw them sideways. So maybe for yourself on your notes here, beside here, you write 3x. And then there's a plus 2, so beside these two, I'm going to write my plus 2. And again, on the computer they were red. I like the same color. And I like coloring. So I'm going to color them in green. Oh, such a good coloring job. So, there's my 3x, there's my plus 2. When we have things that are negative, so beside here, I'm going to write negative 5x's. That's in Alegtiles when we don't shade it in. So anytime you want to show something as an Alegtile with a negative, you don't shade it in. And here would be plus 7. Okay, question for you. What's 1 minus 1?
0.
0. Good. What's 2 minus 2? 0. 3 minus 3?
0.
0. And the idea of the positives and the negative Alegtiles is that anytime you have a positive 1 and a negative 1, they're going to cancel out because you're going to get 0. So I can cancel out this one with this one. Does that make sense? Because I have a positive 1 and a negative 1, right? And these are x's, but it would be the same thing. If you had 1 apple and then you ate 1 apple, how many apples would you have left?
So you
0.
cancel out 3.
Right. You can also, can I cancel more?
Yeah.
Yeah, I could cancel a second one and a second one, and a third one and a third one.
And then you're left with 2 -2.
I'm left with negative 2 x's.
But then you have to do the same for the other side too.
Are any of them negative?
No.
No.
Yeah.
How many little squares am I left with?
What do you leave left with 9?
I'm left with 9 of them. So using the Alegtiles, you just figured out using the Alegtiles that the answer to this is going to be minus 2 x's are left. And then these are all shaded. We have 9 of them. This is our answer. Okay? The Alegtiles really show us that. And sometimes it's really hard in real life for me to show you a negative pencil. Right? I don't know how to pick up a pencil and say, this is a negative pencil. It's really been everything when I talk to it, it just is like angry, it's negative all the time. No, I don't know how to make a negative pencil to show you an example. But in Alegtiles, we have this way of saying positive things we shade in, negative things we don't. So I guess if I drew a pencil and colored one in nicely, and then I drew another pencil and didn't color it in, I guess that could be a negative pencil. And a positive 1 minus 1 is always 0. So a positive Alegtile and a negative Alegtile will always cancel each other out. Now eventually you're not going to want to draw these pictures. If drawing the pictures is what you need to do every question, that's excellent, do that. But eventually what we're going to do is we're going to go through our equation and we're going to say this term, 3x, is alike with the minus 5x.
So be negative.
And then I would use, I like starting with different symbols. Here I'm circling those because those two are like terms as well. And when I underline or I circle, or maybe you put, if you have a third one, you might put a square around them. Notice that I also included the sign. I have 3x's minus 5x's. And we have to think of our integers. Here's my number line. If I have 3 of something and I minus 5, subtracting is always going in this direction. Where would you end up if you started at 3 and went back 5? Well, 3 would get me to 0. And then 2 more would get me to -2. Notice that's what we got as our answer for the x's. So if you're able to do the integer math, it's often quicker than the Alegtiles. But, as you all noticed on the first one that we did, where do we make lots of mistakes? It's in our integer math. Sometimes it's confusing, like -3 minus 8. Some of us want to say 5. Some of us want to say 11. Which one is it? Do I have to draw a number line every time? Maybe. Right? But that's what we're going to do. We're going to be practicing a lot of integer math. And then the circled one, +2 + 7. That's pretty easy to get +9, right? So in algebra, we can just look at the algebra and add the like terms. That's going to be the shortest way to get the answer. But today, we're showing how drawing out the Alegtiles and knowing that a +1 and a -1 would cancel each other out is a really nice way of seeing what's left. So let's look at our second example. 5x's. So first of all, 1 x's are rectangles. Do I shade these in for a 5x?
Yeah.
Okay. Those are 5x's. And the next thing I have is +2x's. So I'm going to draw draw 2x's. Do I shade these ones in?
Yes.
Yes.
But would it not be the little squares?
That's going to be 2x's. The little squares are 1's. And 6x squared. Oh, at this point I wish I would have started drawing a little smaller. 6x squared, those are the big boxes, and the big boxes have to be the same height or the same width. Oh my goodness. They have to be the same size as the little x's. 1, 2, 3, 4, 5, 6 of them. Do I shade these ones in? Oh man, I gotta take out a crayon. Purple. Oh yeah. Shade them in. So shaded in means positive. Those ones will be my 6x squared. Okay. Are any of them empty? No, I can't do any canceling out. So what if I put things together? How many big boxes do I have? 6. So I still have 6x squared. How many little rectangles do I have? 7 of them. This is the final answer. 6x squared plus 7x. Okay? If you wrote it like this, maybe you counted the little ones first. That's right as well. Right? If someone says, hey, what do you have? And you're holding 2 oranges and 3 apples. And you say, I have 2 oranges and 3 apples. And they say, no, you're wrong. You have 3 apples and 2 oranges. And you're like, okay, buddy. That's the same thing. Same thing in math. Both of those mean the same thing. I'm not going to mark you wrong if you write one of the ones first and the other one second. Mathematically, mathematicians prefer if we have the bigger degree first. So the x squared has an exponent of 2, which means it has a degree of 2. The x has an exponent of 1 if you put on your math goggles. And so it would have a degree of 1. Mathematicians like it if you start with your biggest degree and go down to your smallest degree. That's sort of like formality. But both are right. And so unless you're at like a very, important math banquet where formality is there, you have to use the right fork and the right knife and put your polynomials in the right order, I will accept both of those. Now, can you see that if you underlined the 5x, that the plus 2x is a like term? But the 2x and the 5x are not like terms with the 6x squared. In order for things to be like terms, the variable and the exponents with the variables have to be identical. But the number in front doesn't matter, because the number in front is telling you how many you have. You had 5 of these x's, and then you added another 2 of these x's. That gives us 7x. This one, I think, in particular, would be like, oh, I much prefer not having to draw everything. Because it was kind of tedious to draw everything, and then in the end is like, really? All I had to do was add up the 5x and the 2x? That was super easy. Okay? Which is great, but the visual of the Alegtiles really helps you see why it is that you're adding like terms. Because these rectangles and these squares are different, just like apples and oranges are different.
We're gonna use this right 5AB and minus 8BA.
So, to be like terms, exponents and variables must be exactly the same. Are they exactly the same here? No. It looks like no. This one has an a with an exponent of 1. Does this one have an a with an exponent of 1? Yes. This one has a b with an exponent of 1. Does this one have a b with an exponent of 1? Yes. The order doesn't matter. They're just switched. But these are still like terms. And this is where one of the nice things about going to that formal math banquet, and a formal math banquet, which do you think the mathematicians prefer? Do you think they prefer AB or BA? What's your guess? What's your gut feeling?
AB.
They prefer the AB. Why? What do you think the reasoning is?
Looks better.
ABC. It's alphabetical. So most mathematicians, it would have originally been like, well, I'm going to write that one alphabetical. I'm going to write this one alphabetical. And then it's really easy. If you always do alphabetical, the like terms are even easier to see. Because you might be tempted to say these aren't alike because that looks different when the order's switched. But the order doesn't matter. And why doesn't the order matter in multiplication? What's 5 times 3?
15.
15. What's 3 times 5? 15. Okay. Which is really helpful because if I give you something complicated, if I tell you that 29 times 31 is 899, what's 31 times 29? 899, right? It's not that, like, they're the same if the order, so the same thing happens here. And now, what will you get if you combine them? Negative 3AB.
Okay.
Now, we never learnt the Alegtile for AB. You can make one up, right? We could make up that this rectangle, which is kind of not as narrow as the X rectangle, but not square either. Maybe that is an AB rectangle. And I need to make, oh, yeah, I'll do that. That's what I'll write. 1, oh my goodness. Yeah. Not happy. I'm gonna start.
Oh, it's because you made it too long.
I know it didn't. I drew it too slow.
Zero.
There's. I'll redraw it. There's my AB rectangle. 5 ABs. Would I shade them in
No.
for 5 ABs?
Yes.
Yeah.
Yes. Get my crayon out. 1, 2, 3, 4, 5. I just made up a new algetile. This would be 5 ABs. Then I need to minus 8 of them. So I go 1, 2, 3, 4, 5, 6, 7, 8. This would be minus 8 ABs. Correct? Would I shade those in?
No.
No. What's 1 minus 1?
Zero.
0. So if you have a positive 1, you can cancel it out with a negative 1. Can I cancel it more?
Yeah.
Okay. If those are all canceled out, what do I have left? I've got negative 3 ABs left. Okay? Drawing it out can be really helpful for the positives and negatives. Again, another thing that can be really helpful for the positive and negatives is the number line. There I'm at 5, right? I have 5 of something. I minus 8. Minus is going in this direction, 8. Can you see that 5 would get you to 0? I always go to 0. How many more do I have to do 8? 1, 2, 3 more. That'll end me at negative 3. Number line thinking, super helpful for knowing which direction you're going and helping you get the right number. What are common mistakes here? People get 13 instead. They went the wrong direction. But see how helpful the algetiles and canceling out are? You just have to make up, and like, we never formally learned what an AB algetile is. We just have to make something up. You can make different shapes and call them different things. You have a y plus a y plus a y plus a 3y. So what I would do is if I was doing this work,
Or what?
I'd underline that y. Is there anything else that has just a y? Yes. This one has just a y. Anything else? Yes. This one has just a y. Anything else? Yes. All 4 of those are like terms. How many y's do you have?
3.
Well, 4. Okay, we have 1 here, 1 here, 1 here, 3 there. If I had 1 pencil, 1 pencil, 1 pencil, and then 3 pencils, how many pencils would I have? 6 pencils. If I have 1y plus 1y plus 1y plus 3 more y's, I'm going to have 6 y's.
Easy, no?
So first we have to know what is a like. And I really like underlining like terms, then circling like terms. And when you do that, make sure you include the sign in front. That helps you put things together. Uh-oh, I skipped one. I don't know why. Here. I don't know why it skipped. Example 5, I'll just write on here. Example 5 was 4x squared minus 3x cubed. Are they alike? No. Right? Because the x's are the same, but the exponents are different. So for this one, you would write that they're not alike. Or maybe I actually write it completely out. Not like terms. If you got this as a question, you're already done. There's nothing to do. Which is terribly, like, sometimes math does that to you. You had it on your first worksheet. It said, what's the constant? And there was none. How many people did that bother the first time they saw that question? Right? That happens. It bothered, it's sort of like this one, it says simplified. And how confident would you feel on your test? I don't have to do any work, it's already done. That feels like the last thing that would happen on a test, but sometimes in math that happens. This one has no like terms. Be confident and say that you're done.
Yeah.
You're gonna do one more question.
Una pregunta, ¿y qué energizante usted bebe para mantenerse despierto y no tener una fiesta de colegio?
We're gonna do one more example, then I'll get your question, okay? So we got example 6, and then we'll get time to work on stuff. So example 6 had negative 6m's plus 4n's minus 5n's plus 8m's. So first thing I would do is I'd underline the first one, minus 6m's. Are there any other terms that just have an m? The last one, the plus 8m. So I'm going to underline that as well. And I'm going to take out, if you have the same color, then I'm going to switch to circles. I'm going to circle the next one. Is there anything with just an n? Yes. You'll have to circle this one as well. Okay. Now I've got shapes around all the objects or underlined. Let's start with the m's. Minus 6m plus 8m's. Think of your number line. Where would you be? Perfect. I'm going to ask you a question, and once you realize this could help you a lot in your mental math with integers. What is easier for you? Thinking of starting at minus 6 and adding 8? Okay, think on your number line. Start at minus 6, add 8, you get to 2. Or is it easier for you to start at the 8 and subtract 6? You like the subtracting 6 better? Because it's only using positive. 8 minus 6 is also 2. You can do that. Most of the time, we get stuck thinking you can only work left to right. Math lets you do a little bit of mixing around. So if I want to do minus 6m plus 8, I can. Or I could also do the plus 8 first and then subtract the 6. If that's easier for you, but both ways on your number line, you will get to 2. What's easier for you? To start at plus 4 and subtract 5? Where would you end up? Negative 1. And with we can either just write minus n. This is perfectly fine, because with your math goggles on, when you don't write a number in front, put your math goggles on, there's a 1 there. If you write the 1 there, it's not wrong. So if you like it better to write minus 1n, I'm not going to mark it wrong. But when you have 1n, you don't need to write the 1. That's why I've sort of got it there. Like you could see it with your math goggles on, but without them, it's not there. Okay? Is that easier for you to start at the 4 and go back 5? Or is it easier for you to start at minus 5 on your number line and go
Hi,
forward
Bryson
4?
Hollick.
Yeah, he's here.
Okay, he's getting dismissed right now.
Okay.
Thank you.
Let me give you this. Come on, Brandon. Just go chill. Okay. Normally we would have time in class and get as much done as possible and hand it in. You can take it home and get as much done and hand it. Okay, this is where we're going to end today. We're going to get working on our assignment.